Hi, my name is Ethan Nowoski, and this is the Week 6 explainer video for Chapter 18, Question 58. The question asks, the 50 kilograms circular piston shown below floats on 0.12 moles of compressed air. So here's our system right here, where we have our air inside heated at 30 degrees Celsius. We have our piston, which is 50 kilograms. We have our outside atmospheric pressure at 1 atmospheric pressure. We have our height h, which we'll be trying to solve in this problem. And then we have our base, which is 10 centimeters. And part A of the question asks, what is the piston height h if temperature is 30 degrees Celsius? And then we have part B, which is how far does the piston move if the temperature is increased by 100 degrees Celsius? So we're only supposed to solve part B, but to actually solve part B, we'll actually need to solve part A in the first place to find that h, to compare it to our h that we'd find after we add 100 degrees Celsius. And then we have to compare those and subtract. And that'll actually give us our delta H, which is what we really want to know from part B. So in conclusion, we kind of have to do part A if we want to do part B. So for both parts, we're going to be using the ideal gas law equation, which is pressure times volume is equal to the number of moles times the gas constant times temperature. And if the reason we want to use this is because if we break apart what the volume actually gives us, and we have that volume for anything is base times height, and in this case, since it's a cylindrical object, we have volume is equal to pi r squared times the height, and that's what we want to find. So looking at part A, we have our givens, which is n is equal to 0.12 moles. We have our gas constant for air, which as always we know is 8.314 joules per mole. We have our temperature, which is 30 degrees Celsius, and we want to make sure, this is a very important step, you convert that into kelvins, because we have to remember that pressure is in terms of Kelvin and not Celsius. To do that, we just add 273.15 to the Celsius, and that gives us our Kelvin number. We actually don't know what pressure is yet, but we'll solve for that. And then we have our volume, which we have is equal to pi r squared, and we have that our r is 5 centimeters, which we can convert to 0.05 meters. And so we square that, and we get our volume is equal to 0.0025 pi times h. So solving for pressure, actually, we need to acknowledge that the total pressure of the system is the atmospheric pressure, which is the 1 atm, which is why we have this here, as well as the piston pressure. So you want to make sure you also add this atmospheric pressure. I actually made this mistake earlier without adding this, and I got a really wrong number. But if we do that, we add our atmospheric pressure, and we add our piston pressure, which is the force of the piston over the area of the piston. And if we actually do that, we can find that the area of the piston is pi r squared, because it's a circular disc, and our force of the piston is actually just the weight force of the piston, which is mass times gravity, which is 50 kilograms times 9.8 meters per second. And we actually solved for our A earlier when we were working with V with our volume. So we already know that. If we solve for all of this, make sure you convert the atmospheric pressure into pascals, because the pressure is in terms of pascals. And then we eventually get 161,713.74 pascals. And then now all we don't know is the h, and so we can actually plug in all of our values, and then we'll solve. So we plug in all of our values, we just do simple algebra, simple computation, and then we get that our first height is 0.238 meters, right? And so for part B, the only thing we're really changing is the temperature. So we add 100 degrees Celsius, and then we just convert that into Kelvin, which is just the same as adding 100 degrees to the Kelvin. So we have that, and then we literally just plug that change in T into our equation, and then we solve for our H2, which is 0.317 meters. So that's our second height after you increase the temperature. And to find how high it changed, we do height 2 minus height 1 is equal to delta height, and so then we actually get that our delta height is 0.078 meters, or 7.8 centimeters.